Hello, good afternoon, Prof. Bernie. How are you?
Hello, good afternoon, Dr. Fitria.
Yeah, nice to meet you, Prof.
Nice to meet you. Thank you for being our moderator this afternoon.
Yeah, I'm moderator for your session today because Dr. Dini have another activity.
So thank you so much for taking the place of Dr. Dini.
You're welcome, Prof. Bernie. Prof. Bernie, can you share screen, please? You can try to share screen your presentation.
Okay, I'll share screen, my
Yeah.
presentation, so we can check. Okay.
Yes, please. Thank you, Prof.
So can you see now, like
Yeah,
my...
yeah, I can see your presentation, Prof.
Okay, so thank you.
Yeah, I think it's running well. Welcome, Prof. It's
Yes,
good.
thank you so much, Dr. Fitria. So we will just wait for the other participants, also from our students from Central Philippine University. I have actually invited our class, my packaging engineering third year class
Uh,
to attend our session this afternoon.
okay, thank you, Prof. Bernie. How much your student you bring in this session, Prof?
My class would be around 20, I'm not sure,
Ah,
22 or 20, around that number, more or less 20 students.
okay, thank you, Prof.
And maybe some of our faculty members also, I'm not sure, but they were also invited to
Ah,
attend our session this afternoon.
okay, all right. Um, I think we will waiting for Professor Engdani, the lecturer from Merdeka University of Malang, and so his student to join. I will remember in the group, right?
Yes, thank you, Doc Fitria. And so
Right?
I will just wait. We will just wait for the other participants to join. Thank you.
You're welcome, Prof. Good afternoon, Dr. Dani.
Okay. Good afternoon, Mrs. Sunny. Good afternoon, Prof. Bernie.
Good afternoon, Dr. Dani.
Hope all is well with you.
Thank you, Dr. Dani. Dr. Dani, before we start,
Yes.
you can try to share screen your material,
Okay.
please.
Okay.
Yeah.
Okay, I will try. Okay.
Yeah, I'm sorry. It's to make sure that this presentation can run well.
Okay. Wait a minute. Can my slide
Yeah.
is go up?
Yeah,
Okay.
I can see
Okay.
your share screen.
Okay, I will stop screen. Okay, then.
Oh, okay, I will check that the presentation from University of Merdeka Malang and Central Philippine University will try for 30 minutes, right? 30 minutes from the first is who's the first from Dr. Dani, I think, right? Dr. Dani, the first presentation, and
Okay.
maximal is 30 minutes, and then the second
30 minutes. Okay.
presentation is from Professor Bernie, and the time maximized is
Okay.
30 minutes, and then we have 30 minutes again for Q&A, right?
Okay. Thank you very
Okay.
much, Mrs. Sunny.
Welcome. Are you ready for start? If you are ready for start, I will bring back all of the students to come in this platform.
Okay. Inshallah.
Okay. Thank you. I will open.
Okay. Is it Mrs. Sunny will open the class or directly me as a first speaker?
Okay, Dr. Dani, we were waiting and we can start at 1 p.m., right? 1 p.m., right?
Okay, 1 o'clock.
Yes, Dr. Fitria, we can start.
Okay, hello everyone. Good afternoon. Greetings from University of Merdeka Malang. I hope all of you are doing well. My name is Fitria Erika Anwarsani. I am your moderator today, International Collaborative Teaching, with the topic is Lean Manufacturing Philosophy to support MSME and transport packaging design optimization or sustainable packaging. This event is proudly presented to you by the Collaborative Office of International Affairs, Faculty of Engineering from University of Merdeka Malang, and Central Philippine University. To the esteemed speakers of today International Collaborative Teaching is Dr. Dani Yuniawan, STMT from University of Merdeka Malang, Professor Bernie C. Cangrejo, PkgE CHE from Central Philippine University. And to our students from the Faculty of Engineering from University of Merdeka Malang, and to the students from the Faculty of Engineering from Central Philippine University. It's my pleasure to welcome all of you to this collaborative teaching. For all the participants, we will have the Q&A session at the end of each presentation. Please kindly type in your question in the Zoom chat box and kindly state your name, where do you come from, and follow by your question. Now, as we have come to the mind of this event, is the lecture. Please welcome Dr. Dani Yuniawan, STMT from University of Merdeka Malang. He is the senior lecturer in the Faculty of Engineering. Dr. Dani Yuniawan, STMT. Without further ado, the time is yours.
Okay, thank you very much, Mrs. Sani. Very good afternoon to all of you, especially Prof. Beni. Magandang hapon pa po sa lahat. Good afternoon. I try to learn some Philippine. I hope my spelling is correct. Is it? Okay, very good afternoon to all of you. Greetings to all of you. I hope you are all well. It is an honor for me to be able to provide the collaborative lecture. It is our best regard to college, lecturer, and students at the Central Philippine University and University of Merdeka Malang. I will try to base of my knowledge regarding lean manufacturing. Okay, let me share screen for you, all of you. Is the PPT can show up on your screen?
Yeah, we can see your
thank you.
screen.
Okay, my topic is lean manufacturing philosophy to support MSME, micro, small, medium enterprise. I select a simple topic for me because I want to share a simple but meaningful topic to all of you. I will try my best, my knowledge regarding lean. Okay, for the first time, what is lean manufacturing? The lean manufacturing is all about the philosophy to improve work efficiency and productivity, and it's focused on minimizing waste and focus on minimizing inefficiency. Waste in here is the terminology of non-value added activity, because all of non-value added activities in the manufacturing in the company, which is have not bring a value to a product or the service. So waste is seen as anything that customer don't believe in adding value and not willing to pay for. The categories of the waste, usually in lean manufacturing, there are 8 waste category. Previously, prior the year of 2000, there are only 7 waste category, but currently, after post the 2000 and 2010, the classification is at one waste category, that is the unused talent. For the defect, I will start for the left top side. The defect category is the waste from product surface failure, usually related to material handling and work in process rework product. And overall production waste is usually related to high product and rework. and also due to miscalculation of the demand and forecasting data, and waiting. Usually, we'll put on my pointer, and waiting is the waste usually from related to time, yeah, related to lead time, yeah. Every time category in the production which is not bring a value added to the product or the process, or if or the service if the lean itself is applied in the service sector. And unused talent is usually related to underutilization of people talent, skill, and knowledge, while the transportation is usually waste related to inefficient material handling and a lot of backtracking in the shop floor, and the waste for inventory usually related to miscalculation demand data or to repeat order, and is related to overproduction. Really close to overproduction. And waste about motion is usually related to unnecessary movement, related to ergonomic, related to private needs for the operator, and usually related to unnecessary movement of the people. And then the extra processing usually related to working the product beyond the requirement specification that is required for the customer. And how does the lean manufacturing work? Usually, most implementation of the lean manufacturing philosophy are carried out in the process and equipment. Currently, in our curriculum, in our subject, usually we explain the lean manufacturing philosophy in the process and equipment, manufacturing planning, and supplier relationship. And some of them is sometimes simply conveyed in other subjects. So usually some lean manufacturing method also be applied in the service sector. In here we can see that several methods of the lean manufacturing, which is in the process and equipment, manufacturing plan control, even the human resources, the HRD, also can implement the lean manufacturing philosophy itself. And the supplier relationship in the procurement, usually they can implement lean supply chain, or they can implement just in time, or it's about the quality. And then until now, is it still related? Is it still relevant if in 2022 and beyond we implement lean manufacturing? And the answer is still yes. The lean manufacturing philosophy is still relevant today. Until today is still relevant, and the effort of increasing efficiency and productivity. Even though this philosophy is more than 3 decades, actually the 6th decade, yes, the old science is being implemented in the Toyota production system. The origin is the Toyota production system. Lean concept also can help the companies create smart factory equipped with AI, artificial intelligence, IoT, Internet of Things, and operation for smart factory itself, which is included cloud computing, big data, and other software. It doesn't not focus on the human machine equipment relationship. However, the concept, the science still always refer to the lean philosophy concept, and the design of the line production in the smart factory, they will still related to the lean manufacturing philosophy. And then, how many companies use lean manufacturing? Until now, all of the world-class manufacturing companies, most of them is implement almost all lean tools, which is usually currently I observed that there are more than 20 lean tools in the world that usually implement in the world-class manufacturing. Even Tesla, the smart factory, which is use AI and IoT, robotics, and a lot of things, still use Lean Six Sigma in its quality control and TQM implementation. And the most lean tool which is implemented in the production line is 5S. Yes, the 5S is a visual management method, usually the most implement in most all of the manufacturing in the world. And regarding to the industry 4.0, in here, lean manufacturing is actually a human-centric cultural framework. It's regulate the interaction between human machine equipment by minimizing waste while increasing productivity. And lean philosophy can blend seamlessly into industry 4.0 by providing support, increasing efficiency at every stage of the manufacturing process. And the application of industry 4.0 is by the following in developing country is directly related to the high level of the employment workers. Therefore, to implement the smart factory industry 4.0, further feasibility study are needed in the developing country. Currently, we still need lean philosophy method in the industrial sector and service sector, from the scale of the small medium enterprise and until the large industrial scale. And then here is the example of the lean manufacturing. This is the most simple. Usually, they can have the benefit to reduce the spacious floor. We can get more spacious about the lean production by using a 5S, visual management, one-piece flow, and total productive maintenance, which is increasing efficiency and space in the production line, which can be used for another purpose. And in this slide, we'll start with the top left side. In here, you can see my pointer. Oh, my pointer is synced again. Pardon me. Okay, in the top left side, shows the example of the implementation of the autonomous maintenance and unknown system. Unknown system is the light signal, which is shows the condition of the machine, and then the color indicator of the light shows the condition of the machine in real time, which can be monitored through the software interface and other in the computer and through the software of the company. And the top right in here is this is the comparison between push system and the pull system. While the pull system usually namely the Kanban card, Kanban system, where is the shop floor. Where is the shop floor for the pull system? There are two type entities running on the production line, namely the material and the information at each workstation. While in the pull system, the conventional one, there is only one type entities, namely material as the circular entity. And the bottom right, we can see this is the example of the comparison of one-piece flow system in production line. It can be seen that there 3 operators can handle 9 machine process, which have the balanced distribution of workflow. And the bottom left, this one is the example of the application of the visual management in reporting work progress. Whether the color shows the work priority scale. The red color of the paper shows the first priority, and the yellow is the second priority, and the green one is the third priority. The green one can be done after the red or the yellow one is already completed. And then in this slide, we can see the implementation of the lean by using this example of the calculation of the takt time. Takt time is actually the work item, item of the customer demand, which is usually provide the data from the marketing division, which have the data from the customer. They can calculate the takt time for the customer demand, and then from the company, they can provide data for the each cycle time for each process that they have in production line. So the takt time can if all of the workstation can balance the work and can balance the time, which is in order to make the takt time is more balancing, which is with the each of the workstation time. In here, takt time require a pace of production to meet the demand, while the component of other is the number of work in process in the production line. in here we can see that the takt time is required for the rapid working time. The takt time by using the more operator in the production line, then the takt time is more faster. It is depend on the production line purpose. If the demand is very high, then they can add another subcontract operators in order to increase their takt time to make more faster work and more tight lead time. But in here, of course, the cost production cost is very high compared to with the one operator which can handle the 5 machine and circularly and continuously. That is this is another implementation of the lean. We can see in here in the left side, in the left side, there are in the left side we can see the implementation of the one-piece flow. We can see which is the legend says that this notification of working, manual inbound, manual outbound, and machine cycle, and we can evaluate it, each work element of each operator, and we can see the sequence of the work from the line protection and between operator 1 and operator 2, and we can make some improvement by seeing their graph, because maybe there is more work element that can be reduced in order to get more efficient working process. In the right side is the example of the minimizing waste in barista work. You know, the men that provide coffee in the cafe, whether waste is removed and non-value-added activity is removed, and then the total time of the preparation of the coffee to serve to the customer is we can reduce several minutes compared to the upside and the downside. Okay, and in here we can see another implementation of the visual stream mapping. We usually usually they have two visual stream mapping: the current state and the future state. In here, this is example of the current state of the visual stream mapping, and usually they use for the mapping process. Usually mapping all of the waste, from still in the supplier until the final customer. So every waste in the production line, from the supplier until the process of a production line and final customer, if there are any waste we can find, if the company can detect another waste, another non-value added activity, then usually they put the problem, the method how to solve that waste. Yes, usually they will have a comparison between current state and the future state, and usually there is a comparison before and after improvement. And here there is another top, usually 26 lean tools, which is each of them there is a method to make continuous improvement. Actually, we in our subject in the class usually maybe only half, not until half of the 26 lean tool. And I think from in the internet we can see more than 26, I think, for the lean tools. There are many lean tools which is they can implement with different purpose, with different location in the factory, which have the same outcome, which is to reduce the waste or non-value activity. And related to the topic this afternoon, of course, in order related to the MSME, the micro, small, medium enterprise, we all already suffered to the pandemic COVID-19. In this graph, I have some World Bank data, which have the data from time frame within 1995 until 2021, which is so in here we all in the Asian, not only Asian, I think all of the world usually suffer the downline, the downline of the GDP. which have the show that the economy is all in the world is down, yeah, not only in the Asian, I think all of the world. And in here the most effect of the pandemic sector usually in the SME, there are the most significant effect on them. And then in here we can see the manufacturing percentage of the GDP. In here they also have a decline. I think in here not seem clearly enough to see the downline because of the data is very wide in here from 1960 to 2021. All of the country, because of the COVID-19 pandemic, the effect is suffers economically. And MSME is actually in Indonesia is the most important pillar in Indonesia economic, which is the almost 99% are engaged in the business sector, and 82.9 which is have felt impact of the COVID-19 due to the pandemic. The crisis due to this pandemic is more severe than the monetary crisis in 1998. The problem is the same that arise in the MSME are most related to marketing, sales, distribution of raw material, and supply chains, and human resource. Of course, the financial capability, and then in the way, indeed, the way to rise economically is not only from the implementing lean philosophy in the MSME. However, at least by the implementing the lean manufacturing philosophy in the SME, we hope that it will increase the productivity and the efficiency, which will indirectly lead to the economic revival of the SME. And then the government of Indonesia is also try some policy regarding to the pandemic effect to the SMEs. They supports the aid is something like the social support, tax incentive, and then the credit restoration, relaxation of the credit, and then they give the governments also provide capital stimulus, and then some of the SME usually they have collaborated with the SOE, state-owned enterprise, which is also they have to provide the workshop, the training regarding to the marketing, how they can use the social media as the market, as the digital marketing, and then and how they can learn something from the online marketplace. And for the key main tool used in the SME, it shows that the lean tools are often used in the SME can be seen in the table 5. The key main tools which is used, maybe they don't know about the name of the value stream mapping. Maybe they name the terminology may be different, I think. Sometimes, for example, in our company, there is a factory A, which is they can use the TPM, but in the factory B, they maybe the terminology is different. And in this factory C, maybe another name of the TPM is they know about the concept, but maybe the terminology is different. And this is the key main tool that's usually used in the SME. They know how to mapping the problem. Value stream mapping is the purpose is to mapping the problem where is the waste location in their company, and then the critical success factor of the MSME also provide in the table 8, which is mostly is employee involvement, effective leadership, and top management, training, education, organizational culture, which is related to the vision, commitment, and then this is the most all of the SME in Indonesia which is related. The critical success factor is about the financial capability, supply chain integration, and good communication with the supplier and the customer or the reseller, and then personal experience and lean mostly support in this technical factor. And then the critical success factor also act as a barrier of the SME because they don't have the power. Mostly in Indonesia, yeah, I have this data from several reference paper. Mostly in the SME, the barrier is about don't have the power to influence the supplier networking, and the lack of the vision, commitment, and support for the management. And then the workforce fluctuation, because the workforce in the SME sometimes they can use the subcon operator or using different operator in day by day and something like that. So the lean knowledge may be different between the operator. And then lack of adequate lean process skill at the higher level management and supervising. Poor process and quality control and the system, especially for the SME, which is have the business process on the food business process, the F&B, usually they sometimes they don't care about the food grade, something like that. And then the customer relation, usually they lack of the infrastructure and facility, and then they resistant to change the part of in the middle manager. So the turnover of the human resource, the turnover of the human resource is very high. Usually, if we want to have the benefit of developing SME by implement lean tool, they must have pairing one method with another method. So if we implement only one method, usually they don't have a significant impact by implementing lean in the SME. But if they implement pairing with another, more than one or more than two or more than three methods combining together implement in the SME, they have benefit. I think they will have the benefit by about the stock reduction, quality improvement, productivity, and cycle time reduction, and other things in here. I think that is my presentation. I hope that if we can, I think I just the small thing thinking about the lean in daily life. If we can try to reduce all of the non-value added activity, I think we can make it as a culture, as a habit. So from there, I think the boundary of the system, we start from our room, start from our home, and then the next is the environment around you. And then if everyone understands the lean philosophy and how to reduce the non-value added activity, I think we can rise together economically, yeah, against the pandemic. I think I'm sorry for if my English is not good. It's really long time not speaking like this. Thank you very much from here. Thank you very much. I think we can back to the moderator, Mrs. Sanimo. The time is yours.
Well, thank you. Thank you so much, Dr. Dani Yuniawan, STMT, for a very insightful presentation about lean manufacturing philosophy to support MSME. Okay, for all the participants, we will have the Q&A in the end of this session. Please kindly type in your question in the chat box in the Zoom. Kindly state from your name, where do you come from, and follow by your question. Next, we will listen the lecture by Professor Bernie C. Cangrejo, PkgE CHE from Central Philippine University. Professor Bernie, the platform is yours.
Thank you so much, Dr. Fitria.
Welcome, Prof.
And so a pleasant afternoon, everyone, to Dr. Dani, my partner speaker, to Dr. Fitria, our moderator, and to the engineering faculty and students of University of Merdeka, Malang. Selamat tinggal. Greetings from Central Philippine University, Iloilo City, Philippines, especially from the College of Engineering and the Packaging Engineering Department, faculty, and students. And let me acknowledge also my students, my third year packaging engineering students, my class, who are now attending our class session this afternoon. And so let me now give the title of my presentation. And so my presentation is all about transport packaging, design, and optimization. And I think this is very much related to the talk of Dr. Dani earlier about lean manufacturing, about eliminating waste and improving the process. And so when we say optimization, for example, in packaging, and so that would mean also reduction of waste or optimizing the materials that we are using when we design our packaging. And so let me start by saying that when the COVID-19 pandemic happened, it has actually greatly affected the packaging industry. Well, in fact, almost all or all industry for that matter. And so with that, the consumer behavior patterns have also changed because of the different requirements, the different choices, and the different designs that must fit already the pandemic situation. And so with the pandemic and the crisis, there is also a need, or there is also a pressure to reduce the packaging cost. And so one factor that can be used to reduce the cost of the packaging is when you make the proper or the correct packaging design. And so let me define first what we mean by packaging design. And so packaging design is the art, the science, and the technology of enclosing and protecting products within a container or package. And I will emphasize on protecting the products, which is actually one of the major functions of packaging, which I am now to discuss. And so when you talk about the purpose or the goal of doing packaging design, it is really to meet the four functions of packaging. And what are now these four functions of packaging? Number one is that with the packaging, you should be able to contain and transport your products or your goods. With the correct packaging, you can protect and preserve the contents of your package, which would be your goods and your products. Another function of packaging is to be able to inform and sell the product. And finally, one other function of packaging is for you to be able to utilize or be able to conveniently use the product. So with proper packaging design, you can open, you can close, you can say, for example, use your product with the aid of the packaging. But in all of these functions of packaging, it should be that the design of your packaging should be cost effective. And when we say cost effective, it should be the lowest cost, but at the same time, be able to deliver the functions of the packaging, which I have just mentioned. And when you talk about packaging design, there are four areas and there are four options. What particular area or option related to packaging design will you do? And so there are three focus areas. And so the first focus area is related to designing the structure of your package. And so that would be related to the format and material. Will you use a bottle? Will you use a box? Will you use a bag? Will you use plastic material? Will you use paper, metal, wood, glass material? That would be related to structural packaging design. When you talk about graphical package design, this would be related to the graphics, to the arts, to the label of your package. And finally, the engineering package design would be related to the process, related to the production, related to the filling of your container with your product, for example. And so this would be related to the operations, this would be related to the machines that you will use in packaging. And the one that I will focus in my discussion this afternoon is on structural package design. How can we optimize our structural package design? Okay, and so when you talk about structural package design, there are several levels of your packaging that will require design. And so in packaging engineering, we call them the primary packaging, the one which is in contact with the product, and then you put your primary packaging inside a box, and we call that secondary packaging. And then you combine all your boxes, you call that transit or tertiary packaging. And this is another example. So you have your primary packaging, which is a wrap or a wrapper, and then put it on a plastic pouch. And then the plastic pouch is again placed inside a box, and all the boxes now will be unitized using a pallet. And so at every aspect of these levels, it will require you to design optimally your packaging. And so this is another example. So from primary to secondary, and then you add your other elements, like you add a cushioning, you add a protection for your product, and then finally you have your tertiary packaging. And so our focus, take note that the title of my presentation is on transport packaging. And so that would be related to our secondary and tertiary packaging, our shipping containers. In fact, I will be defining what we mean by transport packaging. And so transport packaging is also known as distribution packaging, or they also call it the shipping container. And so the shipping container or your transport packaging is a shipping unit that provides containment and protection to goods during handling, storage, and transportation. So most of the time, we design the packaging of our product, the primary packaging, but oftentimes we forget about the transport packaging. And so what would be the use of a very beautiful packaging for your bottle if it will not be able to reach your destination because your shipping container was not properly designed? And so these are now examples of transport packaging, very popular, almost above 90% of transport packaging being used would be your corrugated boxes. And during the pandemic, they were actually able to come up with a corrugated box that will contain ready to cook or ready to eat food. And so that would be for corrugated boxes. Another example would be your wooden containers, your boxes, and then your crates. Another example of your transport packaging would be your drums and pails, like for your chemicals, powdered products, and so you can put them on drums and pails. Another example would be your shipping sack. So if you have rice, if you have grains, if you have cement, if you have sugar, then you can put them on shipping sacks, transport packaging. And then we also have our so-called intermediate bulk containers. And so intermediate bulk containers would be combinations of different materials that would be used for like bulk, meaning to say many or heavy goods. And so examples of these that would require special needs. Example of these would be your hazardous materials, your chemicals. They are usually transported in intermediate bulk containers. Okay. And finally, we have our pallets. And so pallets are used to combine together your load or to unitize your load. The same is true with your slip sheets. And so these are also examples of transport packaging. And so aside from the materials and the containers themselves, transport packaging would also include all other industrial packaging, and the shipping containers for consumer products. And so it will include also your cushioning. It will include also the loose fill materials like this one, which you put inside your box. They are part of your transport packaging. And so when you talk about transport packaging, it is concerned with the economical preparation, meaning to say, when you transport your goods, the packaging that you should use should be economical. It should be of low cost. And at the same time, it is related or concerned with the protection of the merchandise. And so it should be that it is cost effective, and at the same time, it is able to protect your product. Okay? And so, like for example, in this picture, so you have, we call this one a dunnage. And so this is a inflatable material, or this is now a bag that will contain air, and it will support, and it will try to protect, and it will cushion your packaging and your products during distribution. And so aside from protection requirements, it should be that the design of your packaging should be optimized. And what do we mean by optimized? That means it will achieve the lowest overall cost, and it will balance with minimizing the waste. And so transport packaging, first and foremost, should always be economical, or the shipping container that you will use should always be economical. Okay. And so when you design now your shipping container or your transport packaging, we focus on the protection. Protection from what? Protection from the hazards of handling, of storage and shipping. Take note that when you distribute your goods, the packaging will protect it from fall, from shock, from impact, from compression force, from change in pressure, from moisture, for example, and that is the protection aspect of the design. But it should also consider the economics, like the cost of the packaging material, the labor cost, and also the what? The damage cost. And speaking about optimization, when we say optimization, it is an act, process, or methodology of making something, like for example, your packaging or your shipping container, as fully perfect, functional, or effective as possible. So when we say we will optimize the packaging design, we will make it almost perfect, most functional, most effective as much as possible. In other words, when we say optimization, we say or we mean that it should be the best. And so the question now is, how do you design the best packaging? How do you optimize your transport packaging design? And so specifically, when we talk about optimization, I'm sure all of you engineering students, the packaging engineering students from CPU, and the industrial engineering students from University of Merdeka, you were able to take up calculus as one of your mathematics subjects. So when we talk about optimization, that is actually the mathematical operation of finding or solving the maximum or minimum. And so remember your maxima and minima problems in calculus, that is the process that we will use. And so when we talk about optimization, we want the maxima to maximize and minimize for the best of the product. And so when we say maximize, what is it that we will maximize? And so we will maximize the product protection. But at the same time, we will minimize the cost. And so in our optimum design, we will both do the maximization and the minimization. We want to maximize the protection of your product using your packaging, but at the same time, we want to minimize the overall cost of the packaging that you will use. And so that would sound as if conflicting. How can you minimize the cost if you want to maximize the protection? Chances are, if you want to maximize the protection, the cost of the packaging would be expensive, and so on and so forth. And I will explain the principle or the balance of protection and cost later. Okay, so when we talk about optimum design, as I have mentioned, we will optimize protection of the product using the packaging. In other words, we will maximize the protection. When we talk about optimum cost, we want to minimize the cost of the shipping container or the transport packaging. Okay, and if you will be able to accomplish both, then you have designed an optimum transport packaging. And so let's start and let's focus on the optimum protection. How do you maximize the protection function of your transport packaging? And so in packaging engineering, we make use of this design equation for transport packaging, which is product plus package should be equal to the environment. If you will be able to balance this equation, then you have designed an optimum packaging. And so two ways to increase protection and decrease damage levels. Well, to explain this one, we say that the strength of the product plus the strength of the package should be equal to the strength of the hazard in the distribution environment. If there is a hazard in the distribution environment, if the strength of the product is not enough, then you add packaging so that the packaging will be able to help the product, such that if you will combine the strength of the product and the strength of the package, it will be able to withstand the effect of the hazard in the environment. And when you talk about increased protection, these are the possible ways. Number one is you make the product stronger. So if you will be able to make your product stronger in the first place, then it will require maybe less packaging or maybe no more packaging because your product is already strong. It can already withstand the effect of the environment. But most of the time, you cannot change your product anymore, because if you will change your product, then that means also that the properties will change, and maybe some consumers will no longer buy your product if you will change it. And so if you have no opportunity, if you have no chance of making your product stronger, the second option is to make your package better. Okay? And so that is where we will focus, making the package better. And so when you talk about optimum protection, okay, it can be reached or you can achieve it by taking into account the weakness of the product and the hazard of the environment and the characteristics of your packaging materials, which I have shown in our packaging design equation. Okay, so examples of questions that you will ask is, if you want to design an optimum protection, then know the environment, know the product, and know the packaging. That is basically the process. Okay, so like for example, you should know how severe or how harsh is your distribution environment, how damaging is your environment. Okay, you should know and understand about your product. How fragile, how sensitive, how strong is your product? Is your product soft? Is your product brittle? Is it easily damaged? So that if you will combine the information about the environment and combine that with the information using your product, then you will be able to design the correct packaging. And so you should learn about the characteristics of the packaging that you will use. Is it plastic? Is it paper that I will use so that it will be able to withstand the environment? And so those are the questions that you need to answer. Okay? And so again, remember to protect your product, you must make the product stronger, or you can make the package better. And so this is another way of explaining it. If this is the hazard or the severity of the environment, if this is only how strong is your product, it will be damaged. If you will overpack, if you will put more than what is required of the environment, this is over packaging. We don't like that also. And this one now, if your packaging is not enough, that would be what? Under packaging. What we want is this one. You improve first the product so that the packaging that you will use would be less than. And then finally, make it fit that of the severity of the environment, and what you will get is the optimum packaging and product. And so this is what it would look like. This is the best, the optimized. So before you design your transport packaging, make your product stronger first, if you can do it. And then design your packaging and make it equal to the strength or the hazard of the distribution environment. And that is the optimum design for protection. Okay, and so again, if you will include, so in many equations or in the more modern or in the new equations, we add actually the ecological environment. So if you will combine the effect to the distribution environment and the ecological environment, or to the surroundings or to the nature, that is your optimum environmental packaging. Okay, now we will focus our attention on the cost. How do you minimize the cost? And so the goal of transport packaging, this is the principle, is to minimize the sum of the cost of the packaging material and the cost of the damage. And that can be clearly demonstrated by this one, which is like your cost of protection and the cost of detriment, which is, I think, more clear if I will show you now this graph. This is the cost of the damage and then the cost of the packaging material. And what is the relationship? They are inversely proportional. As you make your packaging material very good, very expensive, what will happen? Then the cost of damage of your product, meaning to say the returns or the damage in the product, would be small. If the packaging cost, or if your packaging is very good, the damage to your product is very low. How about if you will make now your packaging very cheap and not very good? Then the damage to your product would be very high. And so they are opposite. And so you want a cheap packaging, you will have more damage. You want an expensive packaging, you will have less damage, but it would still be expensive. And so what we want is a balance. And that is the optimum packaging cost, a balance of the packaging material cost and the cost of damage. And so if you have the lowest sum or total of the packaging material cost and the cost of damage, that is the optimum cost. And it is somewhere in between. And so it is a good design is that you don't design so that there would be no damage. It is okay to design even if there would be damage on your goods or products, as long as the total of the cost of the damage and the cost of the product would be lowest, which is now given also by this graph. So the optimum packaging system is when the total cost of the package and the damage would be lowest, and that is what we want to achieve. Okay, and so as mentioned, it is the lowest cost. Again, another plot that will show you the optimum cost. And then the most recent model, the optimum environmental packaging model, wherein you include in your cost the environment. And so you have this more complicated plot. And so is it an over packaging or under packaging? And this time you include the effect on the environment, specifically the waste, like what we have, what Sir Dani has mentioned in lean manufacturing, we reduce the waste. And so if you will include the reduction of the waste in your analysis, then you will come up with this particular graph to plot and find your optimum cost or your minimum or your lowest cost. Okay. And so with the different opportunities, I think the example that I will give, which would be most easy to understand, is the principle of lightweighting or reducing the material amount. So you can reduce your cost of packaging if you will reduce the amount or material of your packaging, although there are other ways, but this is the one that I will focus upon. And so this is an example. From this material to this material, the amount of packaging is reduced. And can you also in your drinking bottle, in your purified water, the bottle that is being used is getting thinner and thinner. That is lightweighting, reducing the amount of packaging material, but at the same time still be able to accomplish the function of packaging, which is to protect the product. Okay, and so we want to find solutions that will reduce or minimize the amount of packaging material. Okay, and so one example of that would be IKEA. They simply reduced the dimensions by 1/8 of an inch, by 1/8 of an inch, by 1/32 of an inch, and they were able to save thousands of dollars just by reducing the dimensions and the amount of their packaging. That is just one example. And so what are the techniques? And so I will focus on reviewing the design. Focus on the design of your packaging structure. Okay, and so as I have shown earlier, the shipping containers or the transport packaging that we are using come in different shapes, different sizes, different geometrical figures. And so the question now is, what shape, what size, what dimension of your packaging would give you the optimum design? Meaning to say, the lowest cost, the optimum cost, because there is actually a shape, there is actually a structure, there is actually a geometry that would lead to less waste, meaning to say less material. And that is what I will explain. Okay, so like your this one would be cylinder, your sack, this one would be your box, this one would be your pails. What should be the best shape? And so one should know better, especially if you are a packaging engineering student or an engineering student for that matter. Okay, and so what we will apply is the one that I have mentioned earlier, your calculus. And so an example of that would be for cylindrical containers or for cans. If your packaging is in the shape of a cylinder, what do you want? You want to maximize the volume, because if you have more volume, you have more products, you have more goods, you have more sales. But at the same time, you want to minimize the amount of material. We want the volume to be maximum, but we want the amount of material to be low, because if the amount of material is minimized, then your cost would also be minimized. Okay? And so the question now is, can the dimensions, the proportions, the shape of the package be altered, be changed to reduce the amount of packaging material used, but at the same time deliver the same capacity? And so what is the best shape for a shipping container? Is it a cube, a prism, a cylinder, a sphere, a cone, or a pyramid, or other geometrical figures or shapes? That is the question. Okay? And so this is where packaging engineers and all engineers can employ, can apply what you have learned from calculus, maxima, minima, problems from differential calculus. And so the example of that would be the case of a cylindrical container. And so this is optimization using calculus to find the minimum surface area. I don't know if you have solved this one in your calculus before, but this would be one of the classic examples that can be applied to packaging, to cylindrical containers, for example. And so like if we will apply that to pails or to drums, then that would be most useful. Okay? And so the problem for that in calculus, if you can still recall, would be like this. Find the optimum dimensions. And by optimum dimensions, we mean the most economical proportions for a right circular cylinder. Or this is the same as saying, a cylindrical container has a fixed volume. Establish a relation between the radius and the height for which its surface area is a minimum. Okay? And so what do we want to happen here? We want all the volumes to be equal, but we want minimum surface area. We have a fixed, a constant, the same volume, but the three of them have different surface areas. And when we say minimum surface area, that would mean minimum amount of material. Minimum amount of material would mean low cost in material. And so the question now is, which shape of your cylinder, what relationship of the height and the radius of your cylinder will give you the lowest surface area? And so the question would be, if I will give an actual example, this would be the shape of a sardine can. This would be for a pork and beans can, and this would be for a luncheon meat can. Which of the three would give you the lowest minimum surface area or the lowest amount of packaging material? And so if we will apply our calculus, I will no longer discuss the details of the calculus. And so we will express the surface area as a function of the height and the radius. And we will get the first derivative of the surface area with respect to one of the variable, and then equate that to 0, and then solve the relationship. And so the answer when you will apply calculus is the height should be double the R. It is the one that will give you minimum surface area at a given volume. And so if I will go back to my problem, the winner is the pork and beans. This pork and beans can has height which is equal to the diameter, or the diameter or double the radius should be equal to the height. And so when you design now your cylindrical containers, for you to have the lowest amount of material, this should be the relationship of the dimensions. Optimum packaging, the diameter should be equal to the height. But then take note that there are still other factors that you need to consider. And so why you have a can that is shaped like this? Maybe because your product is long, because your sardines would be like long, or you want flat, or you want greater slices of your luncheon meat. That is why the shape would be like that. But if you will only focus on the cost, if the cost is your only consideration, this is the best design. That would give you the lowest cost of material, the lowest cost for packaging. Because what will happen? If you will now, this is the best, this is the lowest. If you will plot the surface area with the radius, this is the radius that will give you the lowest surface area for a given volume of 1,000 cubic centimeters. And so if you will increase the radius, like it will become the shape, what will happen to your surface area? It will increase. If you will reduce the radius, like this shape of your sardines can, what will happen is the surface area will increase. And there is only one point here that will give you the lowest, the optimum. And that is when the height is equal to the diameter. Okay? And so I have some other examples related to packaging. So like, what is the most economical proportion for an open cylindrical container? The previous problem is for a closed cylindrical container. What if it is now open, say an open pail, or a glass, for example, a glass for drinking. And so the answer, if you will apply your calculus, is that the diameter should be double the height. In other words, your cups and then your glass container should be shaped like this, so that the amount of material that you will use or the surface area would be lost. But again, there are other factors to consider, because if this is shaped like this, chances are it would easily spill. And so most of the time, your drinking glass would be in the shape. or in this shape. But if we will just follow calculus and use only cost as a factor, this is the best shape and dimensions for an open cylindrical container. Okay. And so how about, so like the different cups that you have for drinking coffee, according to calculus, this is the best design. This is the optimum cost design for a drinking cup. If we will use only the factors, or if we will use only the cost as a factor. But as I have said, there are other factors to consider. How about for a box with an open top? This is also another common problem in calculus. And so the box with an open top and a square base, this should be the proportions. Your x, which is now your side of your base, should be what? Double the height of your box. And so don't design it this way. Don't design it this way. Design it this way, because the amount of material that you will use would be most economical or lowest if your x is double the y. Okay? And finally, another application would be, say, on optimum insulation. And so during this pandemic, very popular would be our food delivery system or food delivery companies. And so the question now is, what type or what shape of container will retain the hotness or the warmness of your food? What shape here will make your food last longer in terms of warmth or heat, meaning to say which one will not become cold fastest. And so if we will compare, they have now all the same volume. What are the shapes? We have a sphere, we have a cylinder, we have a cubical container, and we have a block container. And if we will analyze using the same volume, so equal amount of food that you can put there, what would be the surface area? The one with the lowest surface area is the sphere. The one with the highest surface area is your block. Meaning to say, the lower is the surface area, the lower would be the chance for the heat to escape. Because the surface area is small, there is less area for the heat to escape. Therefore, your food will remain hot. Your food will remain warm if the shape is spherical. And so out of the 4 shapes, the best shape supposed to be spherical. And so can you imagine your food delivery company using a spherical food container or delivery container? Again, there are other factors to consider. And so if it is spherical, it would be difficult to carry, whatever, but using mathematics, using calculus, and using our principles in physics, this is supposed to be the optimum design of your packaging. Okay, and so I will finally end. Time check. Oh, it's almost 30 minutes that I have lectured. And so I will leave you with a few quotes related to optimization, related to design. Okay, and so I say now, design like you are absolutely right, and then optimize like you were wrong from the start. And you can achieve success in any area of your life by identifying the optimum strategies and then repeating them until they become your habits. That would be a a thing that you can follow to achieve success. And so finally, I will just try to mention and advertise our Bachelor of Science in Packaging Engineering program. And we are the only school to offer the Bachelor of Science in Packaging Engineering in the Philippines, and that is Central Philippine University. Okay, and I end you with the motto of our students in the packaging engineering department: the strength of the pack is the wolf, and the strength of the wolf is the pack, related to packaging. And so with that, I say thank you for listening. Terima kasih. Salamat gid.
Well, thank you so much, Prof. Bernie, for a very insightful presentation about this topic, transport packaging design, optimization, or sustainable packaging. Now we will, the second is Q&A session. Please kindly type your question in the Zoom chat box. Kindly state your name, where do you come from, and followed by your question. Okay, I will read the question. The question is from Fatkur Rizak from University of Merdeka Malang. And this question is for Professor Bernie from Central Philippine University. The question is for Prof. Bernie is how we reduce packaging costs when demand material rise in the pandemic situation. Thank you, Prof.
Thank you very much, Fatkur, for the question. And so your question is, how do we reduce the packaging cost during, like, for example, this pandemic, when the cost of the packaging itself is now raised or expensive? So my answer to that would be there are many ways that you can reduce the cost. The one that I have focused this afternoon is related to reducing the amount of the material. So if the material is expensive, for example, during this pandemic, then if you will be able to reduce or lessen the amount of material that you will use, and that would translate also to reducing the cost. That is only one method. Other methods would be like optimizing the space during transportation, like optimizing also the kind of material that you will use. Maybe if you will use plastic container, it is expensive. How about choosing other alternatives like maybe paper? And so using alternative materials would be another way of reducing your cost of packaging. I hope that answered the question of that answered the question of that answered the question. Thank you.
You're welcome, Prof. Bernie. Maybe from Dr. and Dani, you can answer this question, or maybe you have the second opinion for optimize the material in the pandemic.
Okay, thank you, Prof. Bernie. I surprisingly, we have the same topic about waste, about the optimization in the production. And Prof. Bernie also bring me several something new that I've never learning before. I think I will underline the answer of the Prof. Bernie. Maybe the Fatkur can make some several about something like the number of the quantity when you are order of the product. So when you order one product, it's different with when you order 10 product and something like that. Oh, there is another question, Miss Ani. Oh, for each for each speaker, for Bernie and for me.
Okay, thank you, Prof. Bernie. Thank you, Dr. Dani. I will read the second question is from Yutia Kairira from University of Merdeka Malang. She has two questions. The first is for Mr. Dani. The question is, can the using of lean tools only be used in the manufacturing industry? If applied in the service industry, how it's applied and what tools can be used, especially to increase the productivity? And the second question for Prof. Bernie, the question is, it's possible shaping sacks can be used on product packaging materials. Doesn't this just add to the wash? Okay, the time is, let me, first is Dr. Dani, I think. You can answer this question from Mutia. Thank you, Dr. Dani.
I will try my best. Lean tools usually mostly used in the manufacturing line in industry, and we also use this philosophy also in the service sector. For something like that, we already provide in the several slides in my presentation. We also make some example of the lean production line, lean manufacturing philosophy in the coffee making, in the barista. So that is for me, the serving coffee, when we grinding the coffee, when we make coffee to the customer, is that is an example of the lean manufacturing philosophy in the service sector. And other, maybe we can make some example in the, for example, in the event organizer. The event organizer, they can implement the SMART mechanism. We separate the internal job with the external job, and we can do several parallels working together by regarding the sequential job, something like that. We can make other example for the lean manufacturing philosophy in the service sector, something like that. I think that would be appropriate answer, because we do some example in the lecture in the classroom. I think that is my answer. Thank you very much.
You're welcome, Dr. Dani. And then for the question is for Prof. Bernie, it's possible shaping sacks can be used on product packaging materials, and doesn't this just add to the wash? The time is yours, Professor.
Thank you for that question. Yes, shipping sacks can be used as a product packaging material, because take note, different goods, different products, different items, for example, will require also different types of packaging. And so there are products that would need, or that would that the best packaging would be shipping sacks. Like, for example, your grains, like, for example, your powdered products. Good packaging would be a shipping sack, in relation as to it would add waste. And so maybe what you can do is improve your sack such that it can be a reusable container or a reusable packaging. So if you can make use of a shipping sack that can be reused several times, and so that will reduce the amount of waste also, although your shipping container is still a shipping sack. Thank you.
You're welcome, Prof. And then the third question is from Antoinette Kreitel Kadigal from Central Philippine University. This question to Dr. Dani: what factors affect lean management, Dr. Dani?
Okay, I will try to answer from Antoine. I think it's depend on the what kind of waste that they have in their company, because I think it's case by case. I think in the factory, in the company A with the company B, they have different waste. What kind of waste they have? So in other of that, the management have the different decision, have the different to taking care of the waste of their production line or in their company. So I think that is the case by case. I think so. It's different, I think, for the company A and company B or something like that. So it's depend on the what kind of waste in their company. So they can taking care of the problem solving, how they can manage the waste in their company. I think that is the will affect the lean management. I think that is, I think.
Thank you, Dr. Dani. Let me check the questions again. Oh, okay. There is no question again, and then I will close this question session, and the result from today's international collaborative teaching with the topic is lean manufacturing philosophy to support MSME and transport packaging design optimization or sustainable packaging is lean manufacturing philosophy is a method which is The same main goal minimize with the various purpose in use in the industry with the application of lean philosophy. It's hoped that it will help to the increase productivity and efficiency. And then the packaging design is the art, science, and technology to be sustainable packaging. We have come to the end of our program, and then please open your camera and let's have a group photo session together. Please open your camera. Let me check. Okay, for the first slide, I will start 1, 2, 3. Right, and then the second slide, I will start 1, 2, 3. And the last slide, I will start 1, 2, 3. Well, for the all participant once again, thank you so much for your participation in this event. I believe we have again a lot of insight of land manufacturing philosophy to support MSME and transport packaging design optimization or sustainable packaging. From Dr. Dani Yuniawan, STMG, and Professor Benny C. Cangrejo, PkgE, CHE. And thank you so much to the Dean of Faculty of Engineering from Central Philippine University, Dean Dani Maulina. Once again, thank you so much and see you again soon. Take care and goodbye.
Thank you very much. Selamat.
Welcome.
Terima kasih.
Terima kasih. Thank you very much.
kasih.
Selamat, Prof. Bernie. Thank you very much.
Thank
Bye.
you, Mr.
Very
Dani.
nice to see you too.
Dr. Fitria. Bye.
Okay,
Thank you, Prof.
bye.
Bernie. I'm sorry if I make mistake. Goodbye.
No, you were a good moderator.
Thank you
Very
very much.
good. Thank you. Bye.
Thank you so
Bye.
much. Thank you, Dani.